Good evening, everybody. This is Akash, URK22BT3007, and today I'm going to explain you what my project is. It is about optimization and mechanistic evaluation of glycerol glucose, natural deep eutectic solvent that is NADES, pretreatment for enhanced extraction of star anise essential oil. Okay, so in this video, I'll tell you what the process is and how I take out my final result. So, for naturally taking out the essential oil, we use solvents like ethanol, methanol, and all solvents. And then we use hydrodistillation and other distillation processes for taking out. But in this, we are using a green solvent and which is eco-friendly also, that is glycerol and glucose. So first we make this sample. That is the solvent. We do it by mixing glycerol and glucose in a beaker and put it in a magnetic stirrer in 1:1 ratio, and and when it reaches in the optimum temperature, it starts to melt and bond together. So after it bonds together, we usually use that and put a certain amount of water in the beaker and then add the star anise from which we have to extract the essential oil, and then the whole process. So I'll start with the methodology right now. As we can see that the glycerol and glucose are mixed together and it is ultrasounded for 30 to 50 minutes. Okay, I'll come to the table first. I'm using the box Behnken Design, which helps me to calculate what the results are in a more optimized way. So in this, I do 15 runs, and in all the runs, the values are different. For example, we see here that -1 is low, 0 is medium, and +1 is high. That is the ratio of the solid and liquid and the water which is used and the pre-treatment time. For example, if we see if the value is 0 in here, the pre-treatment time is 40 minutes, and if it is -1, it is 30 minutes. So it differs. So mostly the thing with the table is in the most 15 runs in which the value comes to the maximum will give the highest yield. So how do we calculate the yield? By taking the values in here and then take first. Okay, let me just come here. So in this, after we mix the glycerol and glucose with the water, we pre-treat the sample, and then after pre-treating it for the particular time, whichever we have to do it, we hydrodistillate it. So the distillation goes like this. So we take a round bottom flask in here and we put the NADES and the glycerol solvent there, mix together, and we add 225 ml of water. And when it heats up with the apparatus, the the thing which is there, it evaporates, as in the essential oil and all goes up, and then it condenses back because the water is there on top, which cools down the substance which is going to evaporate. So from there, we can see that the oil and water both comes down. We separate the water and the oil, and then the oil which is taken out it in a vial, and we calculate it. So for calculating it, we have to calculate the yield oil essential oils yield calculation. So it goes like first the weight of the tube with the oil minus the weight of the tube which is empty divided by 25, which is the amount of star anise which we take for every sample, multiplied by 100. From that, we calculate the yield percentage, and from this, we can see that in which run we get the maximum output. That is, in which process we get the maximum value, so that from that we can take out whatever one which gets the highest yield. We can use it further. Okay. Uh, After I take out the essential oil, we check by doing FTIR and SEM analysis of the sample. FTIR is done to use FTIR is done to see what all are the compounds and the things which are present in the NADES and the essential oil, and it helps us to compare between the both. And with the SEM analysis, we can see what are the structural changes which we can find. So in the control one, only star anise is present and it is not pre-treated, nothing. So in this we can see that the surface is very smooth. That means the star anise thing is not breaking down and everything, and the oils are still inside. And in the second one, we had taken the star anise sample with the NADES solvent and pre-treated, and then it was dried. So we can see that irregularities and the bumps and everything, which tells us that it is irregular and the breakage is happened inside, from which we can conclude that the essential oil can be extracted easily. So the whole process, I mean, the reason for taking out is to see that the essential oil is taken out by the NADES sample, and it due to the pre-treatment, it gives us a better yield rather than the untreated one. That is the control. And then the ultrasound assisted treatment also gives us a better extraction efficiency. Okay, from all this, what do we find? We find that essential oil can be extracted. And star anise, it is an antiviral agent, and it contains high level of skimeric acid, and it is also a digestive aid which can help in bloating, gas, and indigestion, and even constipation. And it helps in the respiratory functions also. And as it is anti-inflammatory, we can use it for many things, and it also has a very good fragrance. So we can use the essential oil for making perfumes also. So the main thing is, by this experiment, that what we find is that with the help of NADES and the pre-treatment of the solvent and the star anise, we can like break down the star anise structure, and then we can take out the essential oil from the hydrodistillation process, which is done by the Clevenger apparatus. And then essential oil can be extracted, and from that essential oil we can do what we want to. As in, if some people want to use it as a medicine, they can use it for cooking, because it can be also used as a flavorant and also as a perfume. So this is my project, sir and ma'am. Yes, thank you.